elementary algebra review tape, we're going to be continuing our work with fractions. We're going to be concentrating on going over problems involving addition, subtraction, multiplication, division of fractions, and fractional equations. There is an earlier review tape dealing with fractions, but these problems are somewhat more advanced. If you're having any difficulty with these problems, of course, you should go back and look at the original videotape lessons. This is just a review lesson. Okay, let's start with the first example. We want to reduce to lowest terms x squared minus x over x squared plus x minus 2. Okay, now fundamental principle of fractions tells us that the fraction a over b is equivalent to the fraction a times k over b times k, where k is some non-zero quantity. In other words, if you were to take a fraction and multiply numerator and denominator by the same non-zero quantity, you will get an equivalent fraction. Or working the other way, if you have a fraction of this form, if you divide numerator and denominator by the same non-zero quantity, you will get an equivalent fraction. Okay, you can think here as dividing numerator and denominator by k, or we could cancel out the k's. The important thing to realize is that canceling out the k's, so to speak, is a form of division. And you can only do that if we have k as a factor. In other words, it's joined by multiplication to the a and the b here. We cannot, if, for example, we had a plus k over b plus k. Here we cannot cancel the k's. Okay? Because over here, the k's are not factors, they are terms. Okay, we add a plus k together. These are terms in the numerator. These are terms in the denominator. You cannot cancel terms. You can cancel factors. Okay? So first we would have to get everything factored out as completely as possible, and then we can look to cancel common factors common to the numerator and the denominator. Okay, so it would be incorrect, for example, to cancel the x squareds or the x's, because what we have here, x squared is a term in the numerator, and the denominator it is not a factor. All right, so let's try to factor the numerator and denominator completely. Let's see what we get. In the numerator, we see that we look for always the greatest common factor, and the most we can take out in the numerator would be an x, leaving us with x minus 1 there. And of course, you can check this by the distributive law, x squared minus x. In the denominator, we do not have any common factor for the three terms, but we do have a trinomial, and we're going to try to factor it in this form. We're looking for two numbers which multiply to minus 2 and add to plus 1. And they, of course, are plus 2 and minus 1. And we check this by FOIL, x squared minus 1x plus 2x, that's plus 1x minus 2. We now have this in a factored form. We see this is sort of like AK over BK. This factor, x minus 1, is factored both the numerator and the denominator, and we can cancel it, leaving us with x over x plus 2. We have this now in lowest terms. You cannot go any further. You cannot cancel the x. X is not a factor in the denominator. It is a term in the denominator. So this is the end of the first problem. Okay. Our second example, x squared y minus xy squared over x squared minus y squared. Once again, before we can do anything, we have to factor the numerator and denominator completely. We're trying, of course, to reduce this to lowest terms. Looking for common factors in the numerator, we see that xy appears in both this term and in this term, and it's the greatest common factor that we can pull out. So taking out an xy leaves us with the first term leaves us with an x, minus in the second term a y. Multiplying out, we get x squared y minus xy squared, which is correct. In the denominator, we have the difference of two squares, which can be written as x plus y times x minus y. And here we have x minus y as both a factor in the numerator and the denominator. We can cancel the x minus y's to get xy over x plus y. And once again, this is as far as we can go. X and y are factors in the numerator, but they are terms in the denominator. We can't cancel anything else out. Okay, let us now go over some examples involving multiplication and division of fractions. When you multiply two fractions, a over b times c over d, we will multiply the numerators and divide by the product of the denominators. However, if it is possible to do any cancellation before the actual multiplication, then we will. When it comes to division, a over b divided by c over d. When you want to divide, what we do is we invert and multiply. A over b divided by c over d, a over b times d over c, ad over bc. And of course, this can either be written in this form, or it could have been a over b divided by c over d in this form. So whether you see it like this or you see it like this, we know that instead of dividing by c over d, we can invert and multiply by d over c. Okay, so for this example, I'd like to do the following multiplication. X squared minus x minus 6 over x squared minus 9 times x plus 3 over 2x. Going to be the product of the numerators over the product of the denominators, but before that I'd like to factor everything out completely, see if we can cancel any common factors out. So, well, the x plus 3 and 2x. As far as we can go. X squared minus x minus 6, there is no common factor to pull out. We do have a trinomial which we can factor as follows. We're looking for two numbers that multiply to minus 6 and add to minus 1, so minus 3 and plus 2. Giving us x squared plus 2x minus 3x, that's minus x minus 6. In the denominator, we have the difference of two squares. For example, a squared minus b squared, you can write as a plus b times a minus b. So here, x plus 3 times x minus 3. Okay, now we can think of sort of extending the fraction line. So this is one big numerator over one large denominator. Because after all, a over b times c over d is just the product of the numerators divided by the product of the denominators. And now we look to see what we can cancel out. X minus 3 is a factor in the numerator and in the denominator. That goes. And x plus 3 as well. We can divide numerator and denominator by x plus 3, leaving us with x plus 2 over 2x, which is, once again, as far as we can go, the x. They're factors downstairs, but they're terms upstairs, and they can't be canceled out. Okay, in example number 4, we have the following. X squared plus 5x plus 4 over x squared divided by x squared plus 4x. This divided by that. Now, if this upsets you and it doesn't look like a fraction to you, of course you could think of this as x squared plus 4x over 1. So let's first make use of our rule for division, which says that instead of dividing by x squared plus 4x over 1, we can invert and multiply by 1 over x squared plus 4x. Now let's try to factor the numerators and denominators completely. Over here, we have a trinomial which we can write as x plus 4 times x plus 1. Two numbers which multiply to 4 and add to 5. X squared plus 1x plus 4x plus 5x plus 4. X squared times 1 over. Now here we have a common factor, x, which can be taken out in both terms, giving us x times x plus 4. And the only factor in common is x plus 4, which we can cancel out of the numerator and the denominator, leaving us with x plus 1 times 1, or just x plus 1, over x squared times x, or x cubed. In our fifth example, we're going to do some work on addition and subtraction of fractions. We have the problem 4x plus 7 over 3x minus 6, take away 3x minus 4 over 3x minus 6, and then add 5x minus 11 over 3x minus 6. Now the rule for addition and subtraction of fractions is if you have several fractions, you want to add two fractions that have the same denominator, you combine the numerators and place them over the common denominator. And subtraction is the same thing. You subtract, you put a minus on there. Okay, so to add or subtract fractions having the same denominator, that's very important. They have to have the same denominator. You combine the numerators and place them over the common denominator. And over here we want to work with fractions, and they all have the same denominator. So we're just going to combine the numerators. Now when you're combining the numerators, be careful. If the numerator, for example, here has more than one term and you are subtracting, you'll need parentheses to indicate that both terms are to be subtracted. So common denominator is 3x minus 6. We have 4x plus 7. Take away, in parentheses, 3x minus 4 plus 5x minus 11. Okay, you can put parentheses around each one, but of course with the plus sign it's not important. The only time you have to have it is with the minus sign, to indicate that both terms here are being subtracted. Okay, this is 4x plus 7. This minus is like a minus 1 to be distributed through the parentheses, giving us minus 3x. Minus 1 times minus 4 is plus 4. And then plus 5x minus 11. All over 3x minus 6. Let us now combine the like terms. We have 4x minus 3x, that's 1x, plus 5x, that's 6x. Plus 7 plus 4, that's plus 11, minus 11, that's 0. So on top we only have 6x over 3x minus 6. Now if we are looking to write our answer in lowest terms, we do see that there is a factor that both the numerator and denominator have in common. The denominator can be written as 3 times x minus 2. 3 is a factor in the denominator. It is also a factor in the numerator. 6x is 3 times 2x. We can now divide numerator and denominator by 3, or cancel the 3's, to get 2x over x minus 2, which is the answer. Add fractions that did not have the same denominator. For example, 5 over 2x plus 3 over x plus 2. Right? Combined, we want to add fractions that do not have the same denominator. So what we do is we use the fundamental principle of fractions. We try to build fractions equivalent to each of these fractions. Okay, and these fractions that we are forming, that are equivalent to these, they should have the same denominator, so that eventually we can combine numerators over the common denominator. The question is, what should we use as our common denominator? You can always use the product of the denominators, and sometimes you can do much better. The technique for finding the lowest common denominator is to factor each denominator completely, and to take each factor the largest number of times it appears in any one denominator. So here the factors are 2 and x, and here it's x plus 2. There are 3 distinct factors, and the best we can do in this particular case, is the product of the denominators. 2 times x plus 2. Okay, so what we're going to do is to build fractions equivalent to each of these having this denominator, 2x times x plus 2. Let me just write this here. 2 times x plus 2. So we're going to replace this fraction by 1, which is equivalent to it having that denominator, and this one as well. Now, of course, we have to do this according to the fundamental principle of fractions. First, we're going to ask ourselves, what did we multiply this denominator by to get this denominator, and multiply the numerator by that same quantity? So to go from 2x to 2x times x plus 2, we had to multiply the denominator by x plus 2. So we will have to multiply the numerator by x plus 2 as well to get an equivalent fraction. Of course, you could say, well, I can cancel the x plus 2's and get 5 over 2x. That's true, but we don't want to cancel the x plus 2's here. This fraction is not in lowest term. We want to put the fraction in this form, which is not in lowest term, so that these two fractions will have the same denominator, and we will be able to combine the numerators. Okay, so don't cancel the x plus 2's here. This was the whole purpose. All right, now what do we do to this denominator to get this one? We multiply the denominator by 2x, so we will have to multiply the numerator by 2x as well. We now have two fractions equivalent to the original ones that we wanted to add, having the same denominator. So we can combine the numerators, 5 times x plus 2 plus 3 times 2x, put them over the same denominator, 2x times x plus 2, and then let's see if we can simplify it all. Distributing the 5, we get 5x plus 10, and here plus 6x over 2x times x plus 2. The 5x can be combined with the 6x to get 11x plus 10 here over 2x times x plus 2. In the next example, we would like to subtract two fractions. 6 over x squared minus 3x plus 2. Take away 5 over x squared minus 2x. Okay, once again, for addition or subtraction of fractions, we would like to have the same denominator so we can combine the numerators. And to determine the LCD, we're going to have to factor these denominators completely. X squared minus 3x plus 2 can be factored into x minus 2 times x minus 1. Let's see, x squared minus 1x minus 2x, that's minus 3x plus 2. And this denominator can be factored into x times x minus 2 by taking out the common factor x. Now, the LCD, lowest common denominator, is determined by taking each factor the largest number of times it appears in any one denominator. X minus 2 occurs here once, so we'll take it once. X minus 1 occurs here once and here no time, so we'll take it once. X is not here, but it does occur here once, so we'll need that. Okay, so in this case, it's not the product of the denominators. That would involve an x minus 2 squared. We just need x minus 2 times x minus 1 times x for the LCD. So what we're going to do is build two fractions equivalent to the original fraction, having the denominator, let's say x minus 2 times x minus 1. Just rearrange it in order.